Good morning, students. This is lesson 5.5 on page 349 in your textbook. I'm also going to be doing several of the problems that are in the textbook too. So you may want to look at the book in this particular lesson. Okay, so today we're going to be doing standard form of the equation. Before we do that, I kind of wanted to review some of the other forms that I had taught you. Okay. And again, on tomorrow's test, I'm expecting you to be able to write these forms from memory. So, but this time, instead of actually just saying the forms, I actually want to talk about why do we use each of these forms. So the first one was the slope formula, which is y2 minus y1 over x2 minus x1. Why do we use the slope formula? We use it to find the slope when you have ordered pairs for 2 points, okay? So if I have 2 points like 1, -7, and then my second point is maybe 1, 2, okay, so I have x and y values for 2 points. I can put those 2 points in and find the slope. Why do we use direct variation? When you have an equation that has no plus or minus in the equation. Now in direct variation, that is implied that there's going to be a coefficient of x, or basically it's going to be multiplied by something, and we kind of think of it as the rule. Okay. When do we use the linear parent function? Mostly when you are creating points in a table. Okay, that's especially true when you have like x equals to y. So in a case like that, it's mostly just like this one's more to just to know that how the whole system works. Okay, slope-intercept form. When do you use that most? You're going to use that most when you are graphing a linear equation, or when you easily need to find the slope or y-intercept because they're actually just written in the equation. If you know what you're looking for, then they're easy to find. Question 5 is point-slope form. When do we use this? When you need to write an equation, but you have just one point or ordered pair and the slope, okay? So in that case, it's more of when you need to write the equations, you have the basic equation sort of like the template, and then you just plug in the right numbers into the right spots. Now that's just review, but today we're going to be learning standard form, okay? So I want you to memorize this form. Standard form is ax squared plus by is equal to c. Let me say that again. Ax squared plus by equals c. That's the standard form. Now, the numbers a, b, and c are numbers in sequence. So what I mean by that is it's less important what the actual values of a, b, and c are. We're not solving for those. Those are not the variables that we're solving for. When you see the letters a, b, and c in order in an equation, then what that just means is these are going to be it's like the placeholder for the numbers that are going to be there in a real equation, okay? So a represents a real number that will be the coefficient of x, b just represents another real number that will be the coefficient of y, and c represents the isolated number at the other side of this particular equation form, okay? Now, the only rule with the standard form is that whatever the values of a and b are cannot be 0. If they're 0, then it ceases to be in standard form. Can c be 0? Yes. Whatever your equation is, once you multiply or solve or find a solution, then the value of whatever c is can be 0, but a and b cannot, because then it will cease to be standard form. Okay, moving on. Standard form is most focused on the intercepts, okay? And if you want me to review what an intercept is, we've been talking about y-intercept a lot because that's very important in the slope-intercept form. But an intercept would be the points where the graph crosses the x and y axis. Now, when you're graphing information, the X and Y axis is just sort of, again, I used the word template earlier. It's sort of like the template that you place your information on, okay? Well, I have graphed a line here on this template or on the coordinate plane. Now, the coordinate plane is basically an x-axis and a y-axis with a graph background so that it makes it easy for you to graph stuff on. Now, as you can see in this particular line, it crosses the x-axis here, and that would be the x-intercept. And it crosses the y-axis here, and that would be the y-intercept. Let me go and fill in what these values are. Let's start with the x-intercept. We start at 0, and I count backwards to -1. So my x value is -1. Now, starting here, we count the y value. Now, typically with the y value, you count up if it's positive from the origin, or down if it's negative. But as you can see, if I go to the actual point itself, it is not up from the origin or down from the origin. It's one point to the left of the origin, but it's not up or down from it. So if you don't go any up and you don't go any down, then its value would be 0. Okay, so this point is -1, 0. Now let's go to the y-intercept. Starting at the origin, we always do the x value first. So I don't go any left or any right in order to find this point. So my x value would have to be 0. My y value, I go up 1, so that would be 1. Okay, so now we can see my x and y intercept simply because all I do is look at the graph and say, where does it cross? It crosses the y-axis at 0, 1. It crosses the x-axis at -1, 0. Okay, now you may have noticed something. Both of these points have the number 0 in them. So I want to read this to you. When a point is an intercept, one of its coordinates is going to be 0, always. Okay? Because again, the coordinate plane is just the place where we write down values. Okay? So since the coordinate plane has specific spots on the plane where the number 0 is that number, those are the spots where the line will cross. Okay, so let me just make something clear. With an x-intercept has 0 as its y value. So wherever you cross the x-axis, the point is going to have 0 as its y value. So like here it'd be 0, 0, -1, 0, -2, 0, -3, 0, -4, 0. If I want to go in the positive direction, it would be 1, 0, 2, 0, 3, 0. So see, each time my y value is going to be 0. If I were to make a table of values, then I literally could just put in 0 for all of my y values. Okay, because, well, table of values really wouldn't make sense here because these would each be representing different lines, because one line cannot cross the x-axis multiple times. It only is going to cross the x-axis one time. So the idea of making a table of values probably isn't correct, but the idea here is that every y value is going to equal 0. Okay? Now the same is true with the y-intercept. The y-intercept has 0 as its x value. Okay? So I'm looking at this one. This is 0x, 1y. If I crossed here, it'd be 0x, 2y, 0x, 3y, 0x, 4y, and so on. Okay? So anytime it crosses the intercept, wherever it crosses at, then the line's going to be 0. Now, I'm going to turn the page here because I have some problems I want to go over with you. Now, if we want to look very carefully, these are the same problems that are actually in the book. Okay. Now, I just want to show you the different types of work that we're going to be doing with standard form. Okay. So, standard form, if I were to give it an emphasis, it would be the intercepts, the points where you cross the axis. So how would you find the intercepts? If, assuming that you wanted to graph this, then how would you find the intercepts? Here are the steps. Substitute 0 for x, or substitute 0 for y. And then solve for x, or solve for y. Okay? So the idea is, in order to find the intercept for one, set the opposite one to 0. So I'm going to go ahead and solve for y first. So what I'll do is I'll substitute 0 then for x. Okay, now go ahead and solve. 3 times 0 is 0. 0 plus 4y equals 24 is the same thing as 4y plus 24. Okay, so in that case, I'll go 4y divided by 4 is equal to 24 divided by 4. Remember IOB? 24 divided by 4, let's see, 6, 12, 18, 24. I think that would be 6. 6 goes into 24 4 times. So, y equals 6. Now, if I were to write this as an intercept, I would write it as an ordered pair where y is equal to 6 and x is equal to 0. How can I tell? I solve for y, so I therefore have my my y value figured out. I substituted 0 for x, so I know then at the intercept point, then it's given, or it's just a well-known fact, that at the intercept of the x-axis, at the intercept of the y-axis, then my x value will be 0. So given that my x value is 0, then I can solve to find out that my y value, in this case, would be 6. Now, what I'm going to do here, let me just move myself down here. I'm going to go ahead and rewrite the same equation, but I'm going to substitute in 0 for y. So I can find the x-intercept. So let me rewrite this. Okay, so 4 times 0 is 0. 3x plus 0 is the same as basically saying 3 plus 0 equals 24. Because the plus 0 means plus nothing. So I'll go to IOB, isolate the x, opposite operations to both sides of the equation. And I end up with x equals 8. So on this equation, I can write it as an ordered pair. I know if my x value is 8, then my y value has to be 0. And I can see this because I solved for x and I substituted 0 for y. So here are my intercepts. My y-intercept is the point 0.06. And my x-intercept is the point 0.80. Okay? So I hope that that's fairly clear. Let's go to problem 2. And by the way, just to ease your mind, if you want to look at these in a little more detail, these are the exact same problems that are in the book. Okay, so graphing the y-intercept. Here are the steps. First, you find the intercepts, the same way we did it in problem 1, and then plot the 2 points, which will be actually on the axes, and connect to make a line. All right, so let me go ahead and start. I'm going to do this the same way I did before. I'm going to substitute 0 for x first. Now I have negative 2y is equal to negative 2. By the way, just since x has nothing in front of it, remember there's an invisible 1 in front of it. So that invisible 1 times 0 is, of course, 0. So now I have negative 2y is equal to negative 2. I'll divide both sides by negative 2. Those cancel out, leaving me with y. Negative 2 divided by negative 2 is equal to positive 1. Remember, it's not negative 1 because a negative divided by a negative equals a positive. Okay, the rules are the signs are the same signs, and the answer is positive. Okay, so my y value is 1. Now, if I were to solve again, but isolating, don't have a lot of room here, so let me just try to do this small. Okay, so now I'm going to substitute 0 for y. X minus 2 times 0 is equal to negative 2. Negative 2 times 0 is 0, so now I have x equals negative 2. Because the 0 canceled out that entire statement right there. Okay, so now I have x equals negative 2. So if I were to write these as ordered pairs, I have negative 2, 0 for this one, and I have 0, positive 1 for this one. Now I want to graph. So negative 2, 0. Let's graph that one first. So I go 1, 2, negative 2, 0, and 0, positive 1. Okay, 0 left, 0 right, and then I go up 1 for positive 1. So now I've plotted my 2 points. So go ahead and connect. Oops, I kind of missed the line there a little bit. Sorry, it's easier to do with the ruler. Okay. Now again, remember, in an ordered pair, you have an x value and a y value. So if you get a little confused, just remember, solve for one at a time. Once I solve for x, then whatever my value for x is goes in there, and the other one is 0. Solve for y, whatever my value is for y, put it in the correct spot, and then x is 0. Okay? Now, let's do problem 3. What do you do when you have a horizontal line or a vertical line? Now, when you have a horizontal line or a vertical line, its equation is going to be very simple. X is equal to 3, and y is equal to also 3. But it doesn't matter, whatever the number is, it's not going to be written in the form of y equals something x, or x something x time plus something y is equal to something. And there's when you have a horizontal line or a vertical line, then you have just an equation with basically one value. So let me just show you how this works. X equals 3. Go to your coordinate plane, and you can go, well, I'm sorry, I wrote 2 different ways. Plot a table of values, okay? So I'll do that first. I was showing you the easy way, but I'll show you the hard way first. The hard way is not harder, it's just easier to understand. So all of my x values are 3. So you can clearly see that this is not a function because my x values repeat. And then just give any values that you want or convenient values for y. Okay? 3, 0, 3, 1, 3, 2, 3, 3. So in that case, I could plot all these different points. 3, 0 would be here, 3, 1 would be here, 3, 2 would be here. Okay, so you can see how I plotted the points. But let me just say the easier way, way 2, is just to draw the line on the spot for the value. My equation is x equals 3, and on my x-axis go to 3. 1, 2, 3, and then just draw a line there. So in other words, if there's no y value in my equation, then that means it's a completely vertical line. Now the same is true with y equals 3. Again, I could plot a table of values. And I can just come up with random values for x. Okay, but again, that's not necessary. The easier way is on your y-axis, go to 3. 1, 2, 3. Make a line. And that's how you make vertical or horizontal lines. Now the second one could be a function because the x values would not repeat. And let me just say, doing it by table, if I have the value 0, 3 would be here, 0x, 3y. Then I have 1, 3, 1x, 3y, 2x, 3y. Okay? So again, if you feel a little more comfortable, make the table of values just so that you know. But if the y value is constant, then that means that the line is going to be horizontal. And the same is true if the x value is constant, then the line is going to be vertical. Okay, so the last problem is changing to standard form. Now in this case, this is written in slope-intercept form. Y is equal to something x plus b, or y is equal to negative 3 over 7x plus 5. Now again, I set it in the form and I set it in the actual equation that's sitting there. So the steps are this: to simplify and then isolate c, or whatever the constant number is. Now a constant is just a mathematical way of saying this is a number that's not a variable, okay, or basically just a random number. It could be 5 like it is here, it could be 12, it could be any number. It could be a fraction, as long as it's just an actual number, like an arithmetic number. So, using the steps we had learned earlier in simplification, we want to simplify this because we want to isolate this, okay? You're like, well, wait, you want to isolate the number? Don't you want to isolate the variable? We want to put it in standard form. And if you remember from the last page, ax plus by equals c. If the thing that you're isolating, or basically putting by itself on one side of the equal sign, happens to be the number, then we have to simplify the rest of the equation. Okay? Now, I'm going to do this the way the book says to do it, but I don't think that all the steps in the book are necessary, but I'll just go ahead and do it that way. The idea is there's a fraction here, and sometimes fractions are harder to work with, so you can make an equivalent equation just by multiplying everything. Basically, it's kind of like, you know, how you reduce a fraction or increase it. We're just increasing the equation, but the equality of the equation is still going to be the same. So I have a denominator of 7, so in order to get rid of that, I want to multiply my entire equation times 7. Okay, now when I do that, then I get 7 times y is equal to 7y. 7 times negative 3/7 x, you can think of the 7 here and the 7 there as canceling. Okay, so that would leave me with negative 3x. Now, I probably shouldn't have canceled that because I now have to hold on just a second. I'm just going to take a peek. Yeah, because I'm distributing 7 into the entire equation here. I just wanted to make sure I was doing that right. So now I have 7 times 5, which is 35. So now I have 7y is equal to negative 3x plus 35. Now, what I want to do is I want to add 3x to both sides. Now remember, you can add or subtract an entire term if you need it to be in a specific spot in your equation. So I have 7y plus 3x. Since those are not like terms, I cannot add them numerically, so I'm just going to write them as an addition statement of 3x plus 7y. Now, 35, or the value known as c in the formula, is going to now be isolated. So I now have the equation 3x plus 7y equals 35. So that may be a little frustrating. You're like, you did all this work and you didn't get a solution. Okay, I want to remind you, I wasn't asking for a solution, I was asking for a form. Okay, sometimes in algebra you're going to do that. You're just going to be asked to simplify something or to change it, to put it in a form that's going to be workable. Not specifically that you have to come up with a solution. Now I know that one of the more confusing things about algebra is, compared to arithmetic, is when you have an answer, the answer may still look like a question. Like in this case, here's my answer, but my answer is basically a question. But just note that it is not necessarily important that your answer look like an answer. It's just you have to do whatever the book or the teacher is telling you to do. Now, I just want to, for a point of clarity here, I wanted to give you this little hint. The value c in standard form is the value b in slope-intercept form. I don't want you to get confused there. Now, I want to remind you that this value, which we normally would call y is equal to mx plus b, is the constant in this. Well, the constant here is actually called c. So once you've done everything to it and isolated it, then you would end up with the value c. Now, I was just going to show you one more thing. I'm going to rewrite the original equation. Y is equal to negative 3/7 x plus 5. If you were to just sort of add 3/7 x to both sides of the equation, then you can actually get standard form without simplifying it. And then you'd have 3/7 positive x plus 7y is equal to 5. And that would also be in standard form. The problem with standard form here is you still have this annoying fraction, okay? But it doesn't say that it has to not be a fraction in order to be in standard form, because I would still have the form ax plus by equals c, okay? So as you can see, I have values for a, b, and c in each of the correct spots, just like I have here. Now, this is just a little observation that I made, that you don't have to simplify the equation and remove a fraction in order to get it in standard form. Okay, hope that helps. One last thing I want to say also, keep in mind the form always is written in the form of positive um, for these values, but obviously if the value of b was negative, then you would just write that as minus. Thank you much.